all we have to do is just use our prompts. Active, not active. Active, not active. Turn on the fan. Turn on the light. Does your Roblox game not have scripted, interactable, animated furniture with proximity prompts? Let me show you how to make that and how to put it in your game. Let me explain it like this. Imagine that your city map has all of these things. You know what? Forget it. I've been working a long time today. In the cold, in the rain. I'm tired. I don't want to do this intro. I'm going to commit war crimes. I'm DefinitelyNotSeal, and I'm definitely getting this over with. Let's finish this furniture here. If you remember part 1, we did the door and the doorbell. Let's finish this with the lamp, sliding window, and the fan. Let's not have another 36-minute video, and let's keep this going pretty quick paced. So, let's start with the lamp. What do we need to do with the lamp? I've got this cool box up here. The reason for this box is basically where the light's going to come from. In interaction, I've got some surface lights for our part, which is this little bulb right in here. There's an invisible cylinder that's going to be where the light's coming from, top and bottom. And then up here, I've got this big surface light that's going to serve as the actual light. So these two are attached to the center, you see right in here. This is basically the display light. This is for show. This is what an actual lamp would look like. This bigger dome. So you've got this nice sharp ring, bigger dome, and then you've got cool shading in between so it looks like a real lamp. Let me show you how we put this together. Let's script this. First, this needs a tag. Our tag is going to be light. That's not light. Our tag is going to be light. Okay, so light tag. Let's throw our module and script it. If you remember, in Server Script Service, we've got furniture, and inside furniture, we have our modules that need to have the same name as the tag. So let's create a module script, and let's name this light. We're going to create a dictionary and call this light, and we're going to return light. Light. All right, now we need our starter function. Light.new equals function. So we've created a dictionary. This is going to hold all our functions for the tag. Then we're going to return the tag dictionary so that our furniture table can take that and activate the new behavior. If you remember, it's going to pass in a model. If you need a quick refresher, feel free to check out the previous video that goes into how we actually developed this furniture script. First things first, though, we've got a light. This guy. So we have an interaction folder, and then we've got all of these surface lights. We also have our switch here with our activate sound effect and our proximity prompt. So here's the most efficient way that I think we can do this. All we need to do is call from our model, find first child, which is add the recursive tag, search for a proximity prompt, and then a sound. Then for the surface lights, all we have to do is loop through the descendants of our model and check, as we loop through the descendants, is the instance a surface light? If it's a surface light or a point light, then stick it inside of a table, just like what we're doing with this light here. So let me show you what that looks like. First, let's fetch our sound and our proximity prompt. Local sound equals model, find first child, which is a sound. The reason we're using find first child, which is a, so that we can add a true after the class name. The class name is the object. You see if we click the sound, the class name here, this is what we're fetching it by. And then we're saying true, meaning it's recursive. Find first child would just look under lamp. But if we add a true here, On this function in particular, this method in particular, it looks through all the descendants of lamp, interactions children, light parts children, switches children, so on and so forth, until we get our sound. We're going to fetch the proximity prompt the exact same way. Copy paste. I'm going to call this prompt, and I'm going to call this proximity prompt. That is the name of the class. So, sound, prompt, let's get our lights. Objects, we're going to make it a table. Now, to make this simpler, let's write a local function and call this compile lights. And what we'll do is we'll say local light objects equals compile lights. Now, what we're going to do here is we're going to pass in the model. This function is basically going to serve one purpose. It's going to take our model here. It's going to loop through all the descendants, and anything in here that is a light of some sort, it's going to compile into a table and then return that table so that light objects becomes a compiled table of lights. Let me show you what that looks like. Local light objects return light objects. I missed my T.
Dot your I's, cross your T's.
4 underscore, because I don't need the index. Instance in iPairs, because it's an array. Model get descendants. And do. Get descendants. Do. Let's make this an array. We'll say if instance is a surface light. If it's a surface light, then, and let's extend this a little bit. Is it a surface light? Or is instance a point light? If so, table.insert. This takes a table, an array, and a value, and it sticks the value into the array. Here's the array. Here's the value. Perfect. Now this will send back a perfectly formatted light objects table that's got all of our lights inside of it. So let's head back here. Let's get our good old Mr. Active variable. Starts off false, and then prompt.triggered. This is our event connection function. Now, this code is going to fire when the prompt is triggered. Active starts off at false, so let's flip active to the opposite of what it currently is. If you remember, to do that, we got to say active equals not active. Let's play our sound. Then we just got to call a new function that we're going to write that's going to go through all these light objects and set their enabled property right here, enabled property to active. So let's type our function here, local function, change lights. Light objects active. Change lights, light objects active. Awesome, super simple. Let's just loop through. 4 underscore light. I'll call it light object in iPairs. Light objects do. Then we just say light object dot enabled equals active. Active is a boolean that we're passing in, so we can set the enabled value to basically just active. Super simple. Here's our lamp. Let's give it a shot. And there it is. Now, do you notice how I have the proximity prompt set to turn on? Let's get the prompt to change too. Let's do active equals not active, sound play, change lights, and then when we're done, we'll say if active, then else. So if it's currently active, then we have to say prompt dot, let me get our wording here, action text equals turn off. If else, so if it's currently off, then prompt dot action text equals turn on. This will add a nice little spice just to make it a little more interactive. Turn off, turn on. Great. So there's our lamp. Let's move on to our sliding window and our fan. All right, sliding window.
Slide, slide, break into your house.
The way I built the sliding window is I've got a sliding glass part with an open and a close sound effect. And I've got the attachment with the proximity prompt. I threw those classes in there, but we're actually not going to need those. Now, I did an important detail here. If you notice, like a real window, the bottom is pushed further in than the top. So if you're looking at it this way and you're opening it, you open it from this direction, there's just enough space up here for this glass to actually slide upwards. And so that's what we're going to do, is we're going to slide the glass upwards. Let's give it a tag, sliding window, and let's write our module script. Same name as the tag, sliding window, local sliding window, return sliding window, just like we did before. Sliding window.new equals function, model. Let's get our proximity prompt and our sounds. Local open sound equals model. Now we are going to have to path to this because we have two sounds, so we can't just call find first child to class. Open sound, we'll do model find first child open underscore sfx recursive. Works the same way as find first child, which is a, but because it's find first child, we actually have to type the name of it. Close sfx. So the way that I'm scripting this is going to require that the open and close sounds are named open sfx and close sfx. Let's grab our proximity prompt. Prompt equals model find first child, which is a proximity prompt. Good old Mr. Open. Prompt dot triggered connect function. All right, let's flip our Boolean here. Open equals not open. And let's play the sound. If open, then else. All right, so if it's currently open, that means it's going to need to close. So let's flip this variable here. And let's close the window. Close sound, play. Over here, it's currently closed. We need to open it, so we'll say open sound, play. Now, we need a function to move the window. So I'm going to write a function and call this move. And then we'll just call move. Now, the two things we're going to need is the model and open. Now, just like the door, to animate the sliding window, what I did is I set the primary part of the model to sliding glass. So the part that actually needs to slide, the model's primary part is sliding glass. And so what we're going to do is we're actually going to pass in model.primary part. Now for our function here, we've got our glass and if it's opening or not. Similar to the door, let's set up an offset code. We'll say if not open, then, okay, if not open, so if it's currently closed, then we need to open the window. To open the window, our offset is going to be vector3.new. Now we need to change the y value. How do we know how much to open it, though? Well, pretty simple. Our sliding glass is going to move up by its own size. It is currently 3 studs tall, so we're going to move it 3 studs up. Let's grab the y of the size, glass.size.y. This is basically the height of the pane, and we'll just slide it up by the height of the pane. We're going to do offset again. This one, though, actually our first one, we're going to set to negative. So this is going to inverse, slide it upwards. This is going to slide it downwards. I know this seems a little backwards, but this is the math that I had written down. I usually have to play with the math to figure out what works once I have the code running. All right, let's make our tween, our good old friend tween. We'll need to get TweenService. TweenService. Let's create a tween. Open tween equals TweenService create. Not function. This is our arguments. What are we trying to move? Glass part. What's its tween info? Let's create some tween info. This is gonna take 0.75 seconds. I think that is the perfect time to take. And I personally like it to where when you open the window, it slows down a little bit before it fully opens. When you shut a window, it slows down a little bit before it fully closes. To get that effect, we say enum.easingStyle.quad. Then we've got enum.easingDirection.out. In is going to make it play at the start. Out's going to make it play at the end. All right, now our goal table. The properties, we're wanting to change the C-frame. And we're setting it to glass.cframe times cframe.new offset. So if you remember with our door, our current glass's C-frame times, which merges these two together, a new C-frame containing our offset value. And so it's only going to move its current position on the Y upwards. So now that that's written, let's finish by playing our tween. Open tween play, and we'll say open tween dot completed. Wait. This will pause the script until the tween is done so that we can't cancel it midway.
I seem to have made an error.
Comma, true. You need this.
It works.
Okay, so for some reason my math was actually backwards. Keep this positive. Keep that negative. Okay, so this is negative. This is positive. Oh, it works, thank goodness. Okay, great. So as you can see, the window slightly slows down when it opens, slightly slows down when it closes. Adds a nice little bit of animation to it. All right, so that's cool. Let's move over to our fan here. Now, to get our fan to work, I have to do 2 proximity prompts. Let's bust this guy open. Interaction. I've got the center part here. I've got the hinge right here. And I've got the light part down here. Now, between the center part and the hinge, I actually have a hinge constraint. This is the tough part. The hinge constraint is facing down. I stuck it on the hinge and attached it to the center part. Here's my 2 attachments in the exact same position and a hinge constraint. Now the hinge constraint, as you can see, again, is rotating downwards. I had to manually rotate this, rotate it downwards, just like this. And it has the attachment 0 set to attachment 1, the attachment 1 set to attachment 0. I also have a sound effect in here to play the sound for the hinge. Basically, all we need to do to turn this on is set the actuator type to motor instead of servo. It goes to motor. I have the motor max acceleration at 500,000 and the max torque at 1,000. All we have to do now is just set the angular velocity and it'll start moving. So let's classify this fan as a fan. I already have the tag set. For the light part, though, all we have to do is set this as a light that we already scripted. And because I have this set up with the activate SFX, the proximity prompt down here in the point light, we stick it on this part. We set the part as a lamp, not the model, the part here as a lamp, so it doesn't grab this prompt. And it should already work. Now we need to go ahead and add a patch to set that to smooth plastic, but check this out. Our light is turning on and off. So let's add some code for the actual spinning ceiling fan. Fan. Local fan. Return fan. This is stuff we've been doing this whole time. Fan.new equals function. Model is going to be passed in. Prompt. I don't want to accidentally grab this, so let's manually path to this. Let's create an interaction folder too. Actually, let's call this main. That'd be a little simpler. So local main equals model.interaction. Local prompt equals main.center part.attachment.proximityPrompt. So this one we're going to have to be a little more specific as to how we layer fans out, but that's okay. Local running sound equals main.hinge.noise sfx. Local hinge equals main.hinge. Let's just do this. There we go. All right. Let's adjust our prompt text with our good old open boy. Actually, let's set this to active. Prompt.triggered, connect, function. Active equals not active. We've been writing this over
And over again.
running sound play. I have running sound here. Where is it? Here it is. I have looped set to true on this. So that means if I play this once, it's going to continuously play. And so because of that, we actually need to set a check. If active, then else. If it's active, play the song. Otherwise, stop it. Otherwise, because it's just going to keep running until it's stopped. So this needs to be stopped because it's going to loop. And then in here, we'll mess with the proximity prompt text too. Prompt dot action text equals turn off. Prompt dot action text equals turn on. All right. We are also going to set our motor speed. Local motor speed. Here we'll say motor speed equals 15. Here we'll say motor speed equals 0. And then we just got to say hinge dot hinge constraint dot angular velocity equals motor speed. Let's go ahead and add a patch real quick to our light. Here's what we can do. We can check if it's a part or if it's a model. We can say local is part equals model is a model. I'm sorry, is a base part. All we have to say here is if is part, then write a new function, change material. Change material, model, active, part, active. If active, then else. We could say local material material equals enum.material.neon. Material equals enum.material.smoothplastic. Part.material equals material. So with that patch put on, all we have to do is just use our prompts. Active, not active. Active, not active. Turn on the fan. Turn on the light. Now we have a perfectly running fan that is super cool.
Voila, our beautiful furniture.
If you found this tutorial helpful, or if you like this content, check out my scripting course in the description, The Basics of Roblox Luau. I'm currently running a thing right now to where if you go down in the description and check out the webpage, I'm actually giving out the first 3 modules of the course for free. So if you're interested, you could actually see some of the course for free without having to pay anything and see if you like it. So check it out, Basics of Roblox Luau.
I sponsored this and I'm tired.
Next week, we're going to finish off with our last few pieces of furniture.
And then I will be free. You better buy the Basics of Roblox Luau or I'm going to sneak into your house and turn into a corn dog. I'll make you gobble me as a glizzy.